Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, find all people with secret. So basically with this problem, what we have is we have integer n, represent the number of people we have, and we have an array of meetings where we have x, y, and time. So x and y are the two people that are meeting together, and time is the time they are meeting at. And we have a first person, which basically is the concept is explained here, where first we have person number 0 who knows a secret, and that person shares it first with this first person. First person is basically a parameter we get in each input, and they share it with that person at time 0, and then this secret is then shared every time two people meet in one of these meetings that have where one of them knows the secret. So if X knows the secret and this meeting takes place, Y at that time knows the secret. If Y knows it and they meet with X, then at that time they will know the secret. So that's the idea. And the goal of the problem is that we want to find the list of all the people that have the secret after all the meetings have taken place, okay? And it can be in any order. So for example, let's say with these meetings, first person is 1. So basically this means at time 0, person 0, like we are told here, shares the secret with first person, so shares the secret with person 1. So now we have 0 and 1 know the secret. Then at time 5, person 1, which already has the secret, shares it with 2. Okay, so now 2 knows the secret. Then at time 8, person 2, because they now know the secret, shares it with 3. So now we have 3, and then at time 10, person 1 shares the secret with 5, because they already know it, and so we share it. And basically now all the meetings took place. We can stop here, and this is a list of the people that know the secret. So that's the idea here. Now, how can we tackle it? Okay, so how can we solve this? Well, the first thing to think about is time matters, right? Because let's say for person 2, let's say we had maybe 2, 3 meet at time 5, right? For person 2 to be, let's say if person 2 has the secret, for them to be able to share it with 3, they need to be have had the secret before time 5 or at time 5. Right? If they had the secret at time 4, then they can share it. Even if they had it at the same time, they can share it at time 5, because the problem says the sharing happens instantly. Okay, but if 2 only got shared, let's say first person is 1 and 2 got shared, 1 shared with 2 only at 6, and 3 never, so far doesn't meet with anyone else, let's assume that. Then in that case, 3 will not know the secret at this point, right? Because time is before. So the first observation we can make is timing matters. Time order matters. Okay? You can only share if it had been shared with you at a time either before that or equal to it. Okay, so let's say to be able to share something, let's say this time is the new time. Let's call this time the new time. New time. So let's say this is the new time, okay? And let's say the previous time for where 2 got the secret is time t, okay? For this to be possible, well, we need time t to be smaller or equal to the new time, right? So let's remember this rule, observation rule, for this rule here. Okay, so now the other thing to think about is, this is interchangeable. Like, let's say 2, maybe the time 2 knew about the secret is 4, and let's maybe just flip this a little bit so that we have 3 here and 2 here. Okay, 2 is still able to share it with 3. The order doesn't matter. Okay, so how do we sort of, how do we do that? Well, we can create a graph that says which person meets with who, or just some sort of map or graph that represents the relationship. But when we do that, let's say this is P1 and this is P2. Well, P1 needs to have in its neighbors P2, but P2 needs also to have P1. Okay, so that's the other thing, is graph indirected. Okay, that's the other thing we need to think about here. Now, when we create the graphs, we want to keep the time because we want to check this here. And so let's just make sure when we do that, P2T, P1T. So this would be the list we keep in our graph. Okay, so now that I explained all of this, we said also that the time order matters. What does that mean? Time order matters, which means basically we need to process 4 before processing time 5. We need to process, if there was time 3, we need to, let's say maybe 1 shared with 5 at time 3. We need to process 3 before processing 4, right? That makes sense, because otherwise we will not be able to check this properly. So how do we do that? Well, something to check something in order, increasing order, you could either use sorted or you could just use a priority queue. Okay, so that's exactly what we'll do here. We use a priority queue to keep track of the times we are processing, and each time we get the time we are processing, we will basically get all the children here. And as we process, each time we process one and we find that this condition is true, okay, and the thing we just got from the priority queue that has the secret already, we just go through all of its neighbors, okay, we go through them, and then if this is true, then we add them to our queue, and then when we pop something out of our queue, we keep track of the ones that have the secret, and we just add the ones we popped. Okay, and then at the end, this is what we return. Okay, so I hope this was pretty straightforward. It will be more clear once we see it in the code. So let's just code it up quickly here. Okay, so let's implement what we saw in the overview. So we said we need some sort of priority queue to keep track of the time, and we need something to keep track of who has the secret. So this can be just a set, because if we add the number multiple times, we want it to appear only the same once. And initially, the problem says only 0 has the secret initially. So let's do that, 0. And we need to create our graph. And we said our graph is going to be each node has a list, right? So it's going to be just a collection, a default dict. And let's use as default a list, okay? And we said that for the meetings that take place between 2 people at some time, we said that we want the graph P1, and we want it to be in both directions, right? So this one has as a neighbor P2 with at time t, and this one has as a neighbor 1 at time t. Okay, and we can just go through our priority queue. And has secret first. We know that 0 has secret, but we don't need to add it because we will pop it here. And so as soon as we pop something from our queue, we will get the person, we will get the time. Let's assume the tuple here is first the time and then the person. And so this will get the time and the person, because we want to pop the smallest time first. We want to process time 3 before time 4. Remember what we mentioned in the overview. And so to do that here, now person's P has the secret, okay? You may say, why do they have it? Because we will add them to the queue only if they are a neighbor of someone who just had the secret, okay? So now P has the secret, so we'll look for the neighbors of P, which means they should have the secret next in their time, okay? And so they should be the neighbor person and then the time, okay? But as we said, they can only have it if the time is after the current time, right? Let's say this time was 5 and this neighbor had the meeting at 3, so before P had the secret, then we shouldn't this NP shouldn't have the secret, only if it's after. So we need to check only if it's after, which means NT is bigger or equal, okay? Because if it's shared instantaneously, so if the meetings happen at the same time, they both will have it. But we also, there is no need to redo it if this person was already had the secret, right? There is no need to do it. So let's just make sure, do this check here. And so in this case, they have it, so we need to add them to the queue so that we can add them to the list that have secrets. We can also do it here, but I'll just prefer to have it in one place. And so what we want to push is basically the time, which is NT, and the person, which is NP. And so later, this one here will also check those who have meeting with this one and see if they qualify to have the secret. And to qualify, basically, the meeting need to take place after this one. That's pretty much the idea here. And once we do this, we can return. Just has secret, but we need to convert it to a list because we are using a set. Now, one other thing that we forgot to do here, which is that this first person is informed at time 0 by person 0 about the secret. So we need to do that somehow. Well, the easiest way to do it is we can just say that the person graph at 0, right, needs to met with first person at time 0. That's another way to do it. And so 0 basically at time 0 met with first person at time 0. Okay. And that should be it. Yep, that should be it. So let's run it. Yeah, we also want to do it in both directions. So person 0 met with first person at time 0. Yeah, basically just to keep the indirectional nature here. So if we run this and submit, it should work. And it does work, okay? Another way to do basically this, what we are doing here, since this is the same as doing this, we just need to add up a meeting between 0 and first person at time 0. That way, basically, they can share the secret between each other. And that should do the same thing like here. And we can submit. It should work. Okay, and that gets accepted. I hope this was clear. Thanks for watching and see you on the next one. Bye.